Welcome, developers. You've seen the headlines, heard the buzz about AI agents, and probably felt that slight anxiety about letting them loose on your production systems. There's a fundamental question lingering. How do we actually integrate these intelligent entities securely and reliably with our critical databases and APIs without it feeling like the Wild West? You might be thinking, what is this model context protocol everyone's suddenly talking about, and why does it matter? Well, MCP, or Model Context Protocol, isn't just another fancy RPC layer. At its core, it's a precise, authoritative framework designed to standardize how AI agents declare their intent, understand available tools, and interact with external systems. It's the architectural blueprint that prevents our negative state. A world where AI agents, though powerful, operate like rogue processes, unchecked and insecure, directly accessing sensitive data and APIs without guardrails, leading to unpredictable behavior, data breaches, and systemic instability. MCP aims to bring order and predictability to this new frontier. So, what's inside an MCP implementation? Think of it like a carefully architected microservice boundary. You've got context objects. These aren't just arbitrary strings. They're structured data defining the operational environment, the agent's identity, and the policies governing its actions. Then there are tool declarations, where agents explicitly state their capabilities and the external functions they can invoke. And crucially, policy engines, which at runtime enforce the rules. In real systems, this shows up when an agent tries to call an API, and the MCP layer intercepts it, verifying every parameter against predefined security policies. It's like you, a seasoned network engineer, designing secure microservices, meticulously crafting the API gateway and security layers that allow intelligent agents to safely interact with your core systems, ensuring no unauthorized access, no unchecked operations. The real power of MCP lies in its interaction models. It's not just an agent blindly making API calls. Instead, an agent expresses an intention to the MCP, which then uses the declared tools and enforced policies to either fulfill that intent or deny it, often after further context negotiation. This loop of request, validation, execution, and response ensures that every single interaction is auditable and compliant. It's how we transition to the positive state, where AI agents are seamlessly and securely integrated, acting as trusted, controllable extensions of your system, enhancing capabilities while strictly adhering to your architectural security protocols and operational policies, ensuring predictability and trust. But what makes this specific protocol so essential, especially when we compare it to the alternatives that came before? We'll dive into that next. Alright, so we've established what MCP is, but the real question, the one many of you are probably asking, is why do I need this? Why can't I just hit an API endpoint directly? And that's a valid developer-centric question. See, when you integrate AI agents with your core systems using raw API calls or basic RPC, you're often left with what I'd call an uncontrolled, chaotic blend of prompt engineering guesswork and fragile API calls. You're essentially granting a black box AI direct, high-privilege access, hoping it interprets natural language prompts into secure, intended actions. You might be thinking, my input validation will catch it, but that's often too late. Without a structured protocol, every new agent or tool call becomes a potential security surface, a potential data exfiltration vector, or just a performance bottleneck waiting to happen. In the previous scene, we pulled back the curtain on why model context or protocols, or MCPs, are technically non-negotiable. Now, let's roll up our sleeves and confront the gnarly technical problems MCPs are specifically engineered to solve, the kind of issues that fundamentally threaten the integrity and security of your AI-driven applications. The most immediate, and perhaps terrifying, is the challenge of untrusted AI access and data exfiltration. Picture this: an AI agent, perhaps a large language model, granted access to your core systems without proper guardrails. It's an uncontrolled, chaotic entity, one API call away from unpredictable data breaches, system failures, or even reputational damage. This isn't just hypothetical, it's the very real fear that fuels skepticism around AI agent adoption, especially on platforms like Reddit, where developers joke that the S in MCP stands for security for a reason. Without MCP, you're essentially handing a powerful, unpredictable tool the keys to your kingdom. So, how does MCP transform this risk into robust security? It introduces a sophisticated API gateway and security layer. specifically tailored for AI agents, acting much like a seasoned network engineer designed secure microservices. Instead of raw, unmediated calls to your backend, every agent interaction is funneled through MCP. This protocol enforces granular access controls, rigorous input validation, and intelligent output sanitization at the deepest protocol level. Think of it as a highly specialized firewall and bouncer for your agent's interactions. In real systems, this shows up when an agent, perhaps trying to fulfill a user request, attempts to query a sensitive database table it has no business touching. Without MCP, that query might go through, potentially exposing PII. With MCP, the protocol layer intercepts, validates the agent's intent and permissions, and blocks the unauthorized request, preventing a catastrophic leak. This systematic approach drastically reduces your attack surface and hardens your application against malicious or accidental data exposure. Beyond preventing outright breaches, MCP tackles another insidious problem: inconsistent tool usage and unreliable agent interactions. If you've ever tried to integrate disparate services, you know the pain. Agents might misunderstand API parameters, send malformed payloads, or struggle to interpret diverse responses. You might be thinking, isn't this just another fancy RPC layer? But MCP goes further. It mandates a standardized version schema for all tool definitions and communication within the agent's context. This ensures that every interaction is predictable, consistent, and reliable, much like a perfectly orchestrated microservices ecosystem, where every service contract is clear. This consistency directly contributes to a highly secure, auditable, and predictably performing AI agent architecture. The quantifiable benefits are clear: reduced debugging cycles, increased agent reliability by 40%, and significantly less in the developer friction when onboarding new tools. It moves us away from chaotic integration toward a state of controlled, reliable interaction. Now, understanding what problems MCP solves is one thing, but how do we actually build with it? That's what we'll explore next. In the previous scene, we dissected the critical technical problems MCPs solve, those chaotic, untrusted AI interactions that keep us up at night. Now, it's time to shift gears. It's one thing to understand the why, but for us developers, the real question quickly becomes, how do we actually build the secure, predictable agent architecture? You might be wondering, what are the tangible tools, the SDKs, the frameworks I need to get started? First, let's talk about the foundational layer: programming languages and core libraries. Python remains a dominant force here, with robust ecosystems like LangChain and LlamaIndex providing high-level abstractions to define agent capabilities and orchestrate complex workflows. But don't underestimate TypeScript or JavaScript, especially for integrating agents within web services or existing Node.js backends, often leveraging specialized agent SDKs that abstract away much of the boilerplate. And for high-performance microservices integrating with AI agents, languages like Go offer compelling options for building efficient, low-latency MCP interfaces. These tools move us from an era of unstructured, vulnerable AI prompts to one where we can build structured, controlled access layers from the ground up. This leads us directly to the heart of MCP implementation: the actual frameworks and protocols that let you define and enforce secure context. Think of this as crafting the API gateway and security layers that allow intelligent agents to safely interact with your core systems, much like a seasoned network engineer designed secure microservices. We're talking about standard RPC mechanisms like gRPC for high performance, strongly typed contracts, or REST APIs for broader compatibility. OpenAPI or Async API become indispensable for strictly defining your agent's tool schemas, ensuring consistent and auditable interactions. I've seen teams leverage these frameworks to explicitly declare every permissible action an agent can take, transforming a potential free-for-all into a tightly controlled, auditable interface. Finally, none of this is truly robust without robust configuration and deployment strategies. Secure context protocols don't live in a vacuum. We need reliable methods for injecting secrets. Think environment variables and dedicated secrets management systems like HashiCorp Vault or AWS Secrets Manager to avoid hard-coding sensitive information. Implementing proper CI/CD pipelines for your MCPs ensures that changes are consistently tested and deployed. And critically, comprehensive observability tools, distributed tracing, structured logging, and real-time metrics become your eyes and ears, allowing you to monitor agent interactions, detect anomalies, and audit context flow. This entire lifecycle approach ensures we move beyond experimental agent interactions towards truly robust, production-ready systems that offer not just functionality, but also auditable predictability. This foundation is key as we prepare to discuss the absolute best practices for building these secure systems. Alright, so you've got your MCP ecosystem and tools humming, but building secure, scalable AI agent integrations isn't just about picking the right libraries, it's about a foundational mindset. Think of it. We've all felt the developer frustration from wrestling with fragmented, insecure, and unpredictable AI agent integrations that constantly break and expose data. This scene is about sidestepping that nightmare entirely. The first pillar, strict coding standards for your MCP interfaces. Consistent clean code isn't just aesthetically pleasing, it drastically reduces vectors for errors and, more critically, security vulnerabilities. Pair that with robust security patterns, granular authorization, controls ensuring agents only access what they absolutely need, and rigorous input validation on every single request. Don't trust agent output implicitly. Always sanitize. It's like designing the blast doors for your system. Every weld, every bolt needs to be perfect. You might be thinking, okay, security first, got it. But what about everything else? This is where performance optimization and comprehensive testing become your best friends. Imagine crafting the API gateway and security layers that allow intelligent agents to safely interact with your core systems, just like a seasoned network engineer designs secure microservices. Every endpoint, every data flow, optimized for speed and resilience, not just functionality. In real systems, this shows up when teams skip thorough load testing on their MCP endpoints, only to find their agent-driven workflows grind to a halt under real-world demand. That's a critical oversight. Robust performance optimization, caching, asynchronous processing, efficient data serialization turns potential bottlenecks into high-throughput channels. And comprehensive testing, from unit tests for individual protocol elements to end-to-end integration tests mimicking agent interactions, validates both security and performance before deployment. It's about predictability under pressure. Finally, let's talk about robust deployment and continuous iteration. A secure and performant MCP means nothing if it's brittle in production. Adopt an infrastructure as code approach for deploying your MCP gateways, ensuring consistency and reproducibility. Implement robust monitoring and alerting for agent interactions, context usage, and potential security anomalies. This continuous feedback loop allows you to iterate, optimize, and scale your agent integrations effectively. Moving beyond developer frustration, this approach leads directly to developer empowerment through elegant, robust, and predictable AI agent integrations, truly unlocking new possibilities for innovation and secure data interaction. We've laid the groundwork for secure and scalable development, but what truly sets MCP apart from other approaches? Next, we're going to take a deep dive into the key technical differentiators of MCP that truly make it a game changer. After solidifying our best practices for secure and scalable MCP development, it's time to zoom in on why MCP truly stands out. You might be thinking, okay, but what makes MCP fundamentally different from just, say, wrapping my existing APIs with some authentication? That's a critical question, and the answer lies in its unique technical differentiators. MCP moves us from the constant battle against fragmented, insecure AI agent integrations, where agents can accidentally or maliciously overstep bounds, towards elegant, secure, and highly scalable AI agent integrations. The first major differentiator is granular context control. Unlike traditional API calls that are often stateless or rely on broad authorization scopes, MCP injects and manages a rich, dynamic context for every agent interaction. This isn't just about passing a user ID, it's about providing specific session details, permitted actions, data access levels, and even conversational history, all tightly scoped to the current agent's need. The measurable value, a drastic reduction in attack surface and improved data privacy, because agents only ever see what they absolutely must see. Closely related is real-time policy enforcement. MCP isn't just setting policies at design time, it's evaluating and enforcing them dynamically at runtime, based on the granular context. This ensures compliance and prevents runaway agent behavior, providing an immediate system improvement in security posture. The next pair of differentiators elevates our ability to manage and trust these intelligent systems. Introspection capabilities. In MCP, allow us to inspect and understand how an agent is interpreting its context and why it's choosing a specific tool or action. This isn't just logging, it's a window into the agent's reasoning process, crucial for debugging, auditing, and ensuring alignment with intended behavior. In real systems, this shows up when you need to diagnose why an agent made an unexpected database query. MCP's introspection logs can show the exact context provided and the agent's internal decision-making path, cutting debugging time significantly. Then there's GASOL, standardized tool orchestration. Remember our central analogy, crafting the API gateway and security layers that allow intelligent agents to safely interact with your core systems, like a seasoned network engineer designs secure microservices. MCP effectively is that highly secure, standardized API gateway for AI agents. It provides a consistent schema and protocol for agents to declare their tool usage and for your system to expose capabilities. This eliminates ad hoc integration chaos, leading to faster agent development cycles and drastically reduced integration errors. It brings order to the Wild West of agent tool usage. Finally, perhaps the most profound differentiator, semantic understanding of agent intent. MCP isn't just about syntax or data structures. It's designed to carry and interpret the meaning behind an agent's request. It understands the goal, not just the command. This means your system can make more intelligent, context-aware decisions about resource access, permissions, and even error handling. It allows for a more robust and resilient interaction, moving beyond brittle keyword matching to genuine intent recognition. The measurable value here is higher operational reliability and a significant reduction in false positives or unintended actions, which translates directly to fewer production incidents and less manual intervention. These differentiators collectively elevate AI agent integration from a risky, bespoke endeavor to a structured, auditable, and inherently more secure engineering discipline. Understanding these core capabilities is vital as we move into the practicalities of implementation. Next, we'll get hands-on, diving into real-world MCP implementation patterns. After diving deep into the technical differentiators of model context protocols, it's time to get our hands dirty. Because understanding the what and why is one thing, but truly building with MCP, that's where the rubber meets the road. And for us developers, that means confronting real-world integration challenges head-on. First, let's tackle securing sensitive API calls. Think about the most sensitive parts of your system, your core APIs. Traditionally, giving any external entity direct access, even a smart one, is a huge security nightmare. Developers struggle with integrating intelligent agents, leading to insecure, unreliable interactions, slowing innovation, and increasing risk. We've all seen the vulnerability of exposing direct API keys or granting overly broad permissions. This is precisely where MCP shines. We can craft an API gateway and security layer for our intelligent agents, much like a seasoned network engineer designs secure microservices. MCP provides that critical buffer. Instead of direct access, agents interact through a tightly controlled protocol. This means granular permissions, robust input validation, and clear invocation patterns, all enforced before any request even touches your core business logic. It transforms a potential attack vector into a managed, auditable interaction. But what about data itself? You might be thinking, how do I truly trust an AI agent with sensitive customer data or even my entire production database? The risk of unintentional data exfiltration or even subtle data corruption is immense if agents can just freely query. In real systems, this shows up when an agent, trying to fulfill a seemingly innocuous request, accidentally constructs a query that returns PII or financial data it has no business seeing. MCP allows us to impose a semantic layer. It's not just about filtering queries, it's about defining what data an agent can even perceive at a conceptual level. Think of schema enforcement and dynamic data masking, where the MCP agent gateway transforms requests into safe, compliant database calls, or masks sensitive fields on the fly. This way, we prevent the agent from ever even seeing the sensitive information, significantly reducing risk and safeguarding your most critical assets. Finally, let's talk about complexity and tool orchestration. As you build more sophisticated agents, they'll need to interact with a multitude of tools, internal services, external APIs, legacy systems. Without a standard protocol, you end up with brittle, hard to maintain integrations, each agent perhaps interpreting tool usage slightly differently. This leads to unmanageable interactions. MCP offers a unified approach. By establishing declarative tool descriptions and a consistent invocation protocol, we transform disparate interactions into a cohesive, observable system. We move from a state where developers struggle with unmanageable interactions to one where they confidently design and implement robust, secure, and observable AI agent integrations. This accelerates innovation with integrity, creating predictable, stable, and easily debuggable agent behaviors, turning complex interactions into strategic advantages. But even with these powerful patterns, the path isn't always smooth. Next, we'll expose the common pitfalls and misconceptions that can derail even the best-intentioned MCP implementations. Alright, we've walked through building secure MCPs, but now let's talk about the pitfalls, the gotchas, that can turn your sophisticated agent integration into a massive headache, or worse, a security nightmare. This is where the aspirational idea of intelligent agents meeting your systems can quickly devolve into chaos, turning into that negative state where your agents are more of a liability than an asset. You might be thinking, how bad can it really get? Well, a common technical failure mode is insecure context handling. Imagine an agent, given too much freedom, inadvertently logging sensitive user data into a non-secure endpoint, or worse, using an overprivileged API key it wasn't supposed to have access to. These aren't just theoretical, they are real vulnerabilities from misconfigurations, like inadequate input validation or failing to scrub sensitive information from agent prompts and responses. It's the equivalent of leaving your core system's backdoor wide open, assuming your new digital assistant will only use the front. Beyond security, we often encounter performance bottlenecks and architectural anti-patterns that cripple agent efficiency. I've seen teams, in their eagerness to integrate powerful LLMs, create overly chatty protocols where agents make dozens of trivial calls instead of a single, well-structured request. Or, perhaps, building purely synchronous agent chains that block execution, turning a potential speed-up into a system-wide choke point. This is precisely where you need to think like a seasoned network engineer designing secure microservices. You wouldn't design a microservice that makes 50 network calls for a single data point, would you? Yet, with agents, this happens when we don't apply the same rigor to context protocol design, treating MCPs as just another fancy RPC layer, rather than a critical, performance-sensitive API gateway. The disconnect between agent hype and practical utility often surfaces here, leading to inefficient and overly complex solutions. So, how do we mitigate these risks and build resilient MCPs? It starts with granular access control. Just as you wouldn't give a junior developer root access to production, your agents need precisely the permissions for the tasks they execute. No more, no less. Implement strict input and output sanitization, treating all agent-generated context as untrusted data. Always. Embrace asynchronous interaction patterns wherever possible to prevent bottlenecks. And crucially, establish robust observability for your entire agent flow. This shifts us from that chaotic negative state to a positive one, where your intelligent agents interact safely, efficiently, and predictably with your core systems, much like a well-architected microservice environment. Building these guardrails into your MCP development ensures your agents remain powerful tools, not unforeseen liabilities. But how well have you truly absorbed these critical concepts? Let's find out. Alright, we've walked through the common pitfalls and misconceptions when building with model context protocols. It's easy to fall into the trap of insecure, brittle, and unscalable AI agent integrations, allowing agents to act like unchecked processes, introducing chaos and data risks into your core systems. But now, let's solidify your understanding with a quick technical challenge. You might be thinking, how do I really test my grasp of secure context? Well, this question aims right at the heart of preventing those unauthorized actions. Here's your question. Given the critical need for secure context handling in MCPs, which of these is the most effective technical strategy to prevent an AI agent from executing an unauthorized or destructive action, akin to a seasoned network engineer securing a microservice endpoint? A. Relying solely on the LLM's internal guardrails and prompt engineering. B. Implementing a granular, runtime policy enforcement layer that validates agent actions against predefined security protocols. C. Encrypting all data transmitted between the agent and the MCP gateway without additional access control. D. Whitelisting all potential API calls the agent might make at design time without dynamic verification. Take a moment to consider your options. Pause. Ready for the answer? The correct choice is B. Here's why. While prompt engineering and LLM guardrails, option A, are important for initial filtering, they are fundamentally insufficient for robust security at a system level. An LLM's internal logic can be bypassed or coerced, And encryption, option C, is crucial for data in transit, but it doesn't authorize actions themselves. Whitelisting, option D, is a good start, but it's often too static. Real-world agents need dynamic context to operate effectively, which a purely whitelisted approach can hinder. In real systems, this shows up when you need to ensure an AI agent, given a user's request, can only access their specific customer data, not all customer data, even if the LLM's internal prompt implies broader access. You wouldn't design an API gateway that just trusts incoming requests, you'd build a robust authorization layer. That's exactly what option B describes. Implementing a granular runtime policy enforcement layer directly addresses the negative state of agents acting like unchecked processes. It's how we move towards the positive state, architecting robust, secure, and highly scalable AI agent interactions, where intelligent agents behave like well-engineered microservices. This layer acts as the indispensable API gateway and security firewall, inspecting every proposed action, validating it against your predefined security protocols, and enforcing precisely what the agent is allowed to do within its given context. It's about proactive control, not reactive containment. This precise control is the developer's ultimate tool for preventing data exfiltration or unintended side effects. Next, we'll explore how you can actively contribute to shaping this vital ecosystem. Alright, you've mastered the MCP quiz and now understand the intricate dance of securing AI agent interactions, but the journey doesn't end here. The real power of model context protocols, much like crafting the API gateway and security layers that allow intelligent agents to safely interact with your core systems, relies on our collective effort as developers. We've moved from that negative state where you're sophisticated AI agents, instead of extending your reach, introduce unpredictable vulnerabilities and compliance nightmares, to a place where we envision AI agents seamlessly integrating with granular control and uncompromised security. This shift from constant dread to peace of mind isn't just theory, it's built by us, by you. Perhaps you're already seeing common pain points with existing integrations, or you found elegant solutions for secure context handling. This is where the community truly shines, like seasoned network engineers sharing battle-tested microservice designs. Now, I'm curious, what's one specific challenge you're facing or have successfully overcome when trying to integrate AI agents securely into your enterprise architecture? Drop your experiences, insights, or even your burning questions in the comments below. I read them all and they fuel our next deep dives. If this video resonated with you, hit that like button to let us know. Subscribe and ring the notification bell so you don't miss out on future developer guides. And for the ultimate deep dive, grab the full MCP Developer's Handbook, a playbook. The link is right there in the description. Thank you for building the future with us. Let's keep innovating securely.